One of the present most obvious and undeniable level physicists has given his perspective as to this issue. Michio Kaku, perceived for his uncommon commitments to the fields of material science, has as of late avowed that the James Webb Space Telescope has found 6 enormous cosmic systems that researchers thought couldn't exist. These disclosures can possibly open up new aspects in our logical comprehension of the universe. The disclosure is both invigorating and progressive, testing existing speculations about the arrangement and improvement of systems. It is, accordingly, worth watching these advancements intently. The confirmation by such a recognized researcher as Michio Kaku highlights the meaning of these findings. Michio Kaku is an outstanding figure in the logical field, a physicist of American and Japanese legacy. He is viewed as a specialist in both old-style trial physical science and quantum mechanics. Dissimilar to a few additional moderate and incredulous researchers, Kaku doesn't have a place with that gathering and has been open to the surprising consequences of the James Webb Space Telescope mission. His eagerness to embrace new disclosures and offer them with the public features his obligation to propelling comprehension we might interpret the universe. We are satisfied that this recognized researcher has decided to end his quiet and freely share what can never again be denied. The energy and nearly entertained tone of the famous astrophysicist are obvious in his remarks on the revelation made by the James Webb Space Telescope, communicating that this has been a feature that has provoked his curiosity. Go along with us to investigate the ramifications of Michio Kaku's revelation of these 6 huge galaxies. Michio Kaku is a researcher who has forever been willing to think about new speculations. All through his life, he has exhibited a receptiveness to thoughts that rock the boat, figuring out that Einstein's conditions of relativity and Newton's regulations, while crucial, are lacking to catch the full intricacy of the universe. Kaku comprehends that the revelation of the new telescope can possibly improve the logical field, albeit large numbers of his associates have not had the option to take on this view. It is causing concern and a sleeping disorder among defenders of the enormous detonation and rivals of quantum mechanics. Nonetheless, this just incites giggling from Kaku. The JWST has uncovered the disclosure of 6 gigantic worlds tracing all the way back to the earliest seasons of the universe. Every one of these cosmic systems contains a larger number of stars than our own smooth way, in spite of having shaped only 200 million to 700 million years after the huge explosion. The gathering of stargazers who made the disclosure has named these amazing worlds universe breakers, on the grounds that, whenever affirmed, they would change our whole comprehension of the universe. The ramifications of these discoveries are critical, proposing that the universe's initial years were definitely surprisingly powerful and complex. Something no longer fits here. The theory of how things came to be lets us know that the universe was a wreck after the underlying occasion. The principal strong articles required huge number of years to shape, and it required millions additional years for the items to arrive at adequate thickness and produce light. The arrangement of intricate designs, like worlds, was accepted to happen a lot later. A portion of the newfound cosmic systems surpassed the smooth way in size, and their massive gleam recommends that they were reasonable, framing many new stars every year, though our universe structures stars just irregularly. It stays dubious precisely when the main universe framed. Analysts have not had the option to decide this up to this point. The main thing that is clear is that at first, there might have just been single stars or gatherings of stars, which at last converged to frame increasingly large groups until bantam worlds created. The little cosmic systems experienced different universes and bit by bit developed. As per past hypotheses, exceptionally coordinated and gigantic worlds could never have existed around then, which brings up the issue of whether the universe is a lot more seasoned than recently accepted or whether complex grandiose game plans grew a lot of earlier. This situation is hard for moderate science to acknowledge, which actually tracks down issues with this model. And a few parts of physical science vigorously oppose tolerating this revelation, addressing expected mistakes in the age. Assessments. Michio Kaku knows about this and had this to say: there are numerous instances of old and misleading hypotheses that adamantly persevere because of the distinction of specific researchers. Large numbers of these hypotheses were possibly exposed when an urgent investigation uncovered their blemishes. Subsequently, the fundamental work in any science, particularly in physical science, rests with the experimentalists who keep the scholars alert and aware. As a matter of fact, on the planet, we have close to zero familiarity with the genuine starting points of the universe. This proclamation from Kaku underlines the significance of persistent trial and error and approval in the logical cycle. The theory of prehistoric cosmic detonation was laid out in 1927 in view of perceptions of the extension of the universe. These information prompted the end that the universe started from a solitary point and has been growing from that point forward. At that point, it was challenging for individuals and researchers to envision a universe with a start and an end. The possibility of a universe that had consistently existed and was limitless truly was past individuals' creative mind. Indeed, even today, researchers actually face hardships in getting a handle on it. However, taking into account these possibilities is significant. By the by, these new discoveries don't fit by any means with what researchers have in view of the theory of how things came to be for such a long time. In any case, science has shown endlessly time again that re-examination and receptiveness to novel thoughts are a fundamental piece of the logical cycle, similarly as the affirmation of specific speculations and perceptions is. At the point when Einstein was a youngster, it was accepted that the stars and planets were immovably fixed in the universe and that these particular designs consumed a characterized space. Nonetheless, we presently realize that all that in the universe is moving. Planets circle stars, stars move inside their systems at many kilometers each second, and whole worlds move quickly through the universe, the destiny of which we can't yet even predict. This dynamic comprehension of the universe challenges long-held convictions and features the requirement for progressing request and transformation in logical idea. Today, researchers are tested to acknowledge awkward bits of insight and comprehend that hypotheses are not outright insights until they are thoroughly tried or affirmed by exact perception. The possibility of the huge explosion arose out of the acknowledgement that systems are getting away from one another, and this distance is relative to their separation from Earth. This perception, known as Hubble's regulation, proposed that the universe was growing. For quite a while, components, for example, vast foundation radiation and the redshift of light from far-off universes and other cosmological designs appeared to help this hypothesis. In any case, it is critical to recollect that previously, individuals who accepted that the Earth was level and that the Sun spun around us likewise had actual proof for their suspicions until occasions or mechanical progressions gave a more clear and more exact picture. Right now, we are seeing a comparative circumstance. Researchers expected the new James Webb Space Telescope to affirm the presumptions connected with the huge explosion, yet all things considered, they have gone over these 6 cosmic systems that appeared to be inconceivable. This advises us that science is continually advancing and that researchers should be available to new disclosures and reconsider existing hypotheses in light of the accessible proof. The surprising finding difficulties the ebb and flow getting it and prompts a reassessment of long laid out cosmological theories. Researchers use redshift as a device to decide specific amounts in the investigation of the universe. Redshift, otherwise called the Doppler impact, alludes to the adjustment of the shade of light as the light sources and the spectator move comparative with one another. To comprehend this, you can envision stopping and watching a vehicle coming towards you. As the vehicle moves towards you, you hear the motor getting stronger. Notwithstanding, when the vehicle passes you or creates some distance from you, the motor sound changes. This is on the grounds that the pitch fluctuates as the vehicle moves. The equivalent is valid for light. At the point when a light source, for example, a far-off star, moves towards us, the light we see shifts towards bluer tones. Then again, when the light source creates some distance from us, the light moves towards redder tints. This peculiarity is called redshift. Physicists have changed over redshift values into velocities and distances for estimation in the investigation of the universe. In any case, it is vital to take note of that little mistakes in these estimations could make colossal impacts. The estimation strategies recently utilized are presently under survey,